All right, welcome, 7.7. All right, I know it's almost Easter, so many of you are going on Easter break already, but try to focus. And if we didn't make it to this point, then happy Easter. Hope you had a great Easter. All right, so we're going to just do examples. This section, this last section, 7.7, is just examples of vector problems. So we're just going to have to practice. We're going to have to do problems together, and we'll go from there. First one, an airplane flies due north, okay? So an airplane flies due north. So if we're going to draw this here, and we'll put it east and west, north and south, east and west, east, west is over here, I'm sorry, and east is over here. Okay? So the plane flies due north 125 miles from Newark to Albany, then to Detroit, 450 west, due west. What is the plane's distance and bearing from its starting point? So, this is what we're looking to solve for. Right there. So, we have our straight up, straight out, and we're looking for this, which is our R, right? And the bearing, which is that theta, right? Our theta. So, let's solve. First off, how do we solve our R? Well, that's pretty straightforward. 450 squared plus 125 squared. R equals 450 and 125. You plug that in a calculator, you're left, you get 467. So 467 miles. Now, how would we find our theta? How do we find our theta? So, well, what's our theta? Tangent theta equals 450, 125. So theta equals 74.5 degrees. Now, here's the key. That's this right here. That's this angle right here, 74.5, right? So, how would we get from here all the way to there? That's the bearing that it needs to be going. Okay, how do we get that bearing? Well, 360 minus 74.5 is 285.5. And that's your degrees. Okay? Because of the way it's going, the way it's heading, from here that way, flying that way, it's starting here, going all the way around to there. That's the bearing that it would need to have in order to go. Okay? All right, any questions? All right, that was good. Problem number one, not too difficult, it's doable, all using the same information. All right, so let's try the next one. Example number two. Example number two. All right, a wide river flows due south. So now once again, all right, we have north, south, west, east. It says flows due south, so the river's flowing due south. A boat crosses the river traveling upstream at a bearing of 60 degrees and at a speed of 30 knots. The speed of the current is 10 knots. What are the bearing and velocity of the boat as it measured from the ground? So now this is a little more difficult because it deals with a few more different technical terms, but think about this. So the boat is going 60 degrees. So this is your 60 degrees. Go up like this. So it's going 60 degrees. So that means that this whole distance all the way down is 30, but we're not there yet. And that's 60 going in that direction, like so. And then the current is going this way, 10, because it's going due south. So this is 60 going this direction, 30, and it's going due south. So we're looking for this information. We're looking for this R, and then we're looking for this theta right here. Okay? So does that make sense? Does that drawing make sense? So because it's going from here, so if it's going from here down to here, it's going 60 degrees, this direction, 30. It's going kind of against it. Then it's going straight down. The current is, remember, the current is south. So this is going straight down. Then we're looking for this r and that. So let's solve for r. R equals the square root of 30 plus 10, right? So what's it going to give us? Oh, I'm sorry. Take into account velocity, which is dealing with the 60 degrees. So we have to take that into account on this one. As opposed to the other one, there was nothing that it was distance. This is velocity. So you have to take into account it's r squared equals 30 squared plus 20 squared minus 2 times 30 times 20 times cosine 60. Why cosine 60? Because that's the degree, that's the angle that it's going, okay? That has to be taken into account. So if you do that, what you're going to get is r equals 26.5. Okay? All right, so 26.5 is that answer. Now, how would I find if this is 26.5, how would I find what my theta is? In this case, you're looking for theta. Can't use your tangent. You can use something different. What would it be? You have to use sine theta over 10, okay, equals 10 sine 60 all over 26.5. Okay, so we have to go back and review and remember your law of sines. The law of sines. Cross multiply, right? Is what you're going to end up doing. All right? I'm sorry, oops, sine 60, sorry. I skipped a step. All right, so now cross multiply, you're left with sine theta equals 10 sine 60 over 26.5. So theta is going to be what? 19.1. And how do you solve that? 10 times, well, sine, what's sine going to be? You can do that on your thing, square root of 3 over 2, times 10 divided by 26.5, and then hit your button. Now, so what's the actual bearing then? What's the actual bearing? So this little degree here is 19.1. What's the actual bearing then of this line? It's going to be 60 plus 19.1. 79.1. Okay? Okay. All right, any questions on that? So your law of sines are going to come in handy in this section. I know even the next question is doing the law of sines. All right, so the law of sines will come in handy to do these types of problems. So you'll need that memorization card that you have. All right, so look at the next one. A pilot plots his course from Fernwood to Glendale at a bearing of 65. Okay, so it's bearing of 65. So let's erase all this here. Start all over again. Okay, so here we go. North, south. It's again north. All right, it says a pilot plots his course. So from the north, goes down 65 degrees. All right, so there's the bearing for that flight. Okay, looks like so. If the wind is 45 miles an hour from 300 degrees, at what compass heading and airspeed should he fly to maintain a ground speed of 350 to compensate for the wind? So this is his bearing at 350, okay? It's then saying that right here at this point, okay, at that point right there, it's 40 miles an hour, okay? So it's blowing him, all right? Oh, we're going here, let's say this is the point, all right? It's blowing him 300 from here at 300 miles an hour. Or at 40, sorry, that was 300 degrees. So everybody see the 300 degrees? So I drew a line, and it started here and went all the way around 300 degrees, which by the way, if I drew this here, it'd be 60, right? Okay, so it's gonna be there, and what we're looking for is that line right there, okay? What we're looking for is that line, so we're looking for R and theta. So what's our R gonna be? What's our R gonna be? Well, R equals what? So using our law of cosines, okay? Law of cosines, all right? Law of cosines, which is this R, right? Is going to be that, and then cosine, right? So here we go. It's going to look like this: 40 squared plus 350 squared minus 2 times 40 times 350 cosine 55. Where did the 55 come from, guys? Where did the 55 come from? All right, watch carefully. Here's where the 55 came from. So this distance is essentially going to be 65 right there. This degree right here. And then the next degree, which is from here to here, is going to be 55. Okay, so this degree here is 55. All right? Okay, so 65 and 55. All right? Now, what do we get? Well, that's where we get that cosine. So we do the math, and you're left with R equals 329. Now what? Well, now we got to find our theta. Well, sine theta equals sine theta over 40 equals, so sine this one over 40, and sine what? 55, sine 55 is going to be over what? 329, good. This angle and this, right? Cross multiplication, and you're left with theta is equal to 6 degrees. So this is 6 degrees, right? So where is it going to be flying? How does he have to keep his flying? He's got to be flying at 329 at what? So 65 minus 6, 59 degrees. So that's how he knows, that's the angle he wants to fly in order to make up for it. All right? All right, so there's example 4 and example 5. Basically, all of these are going to be using your different laws of cosines and law of sines to solve, okay? Let's look at example 5. Let's try example 5 together. A 20-pound box of nails rests upon a 30-degree ramp. Friction exerts a force, UP, up the ramp. The ramp itself exerts its force, called the normal force, on the perpendicular box. What is the magnitude of the normal force? Okay, so here we go. All right, so let's do this one together, and then you'll hate me for life, I can guarantee it. But it's good practice and good for you to try some of these, all right? So it looks like this.